Yeah, this is our sessile droplet drying setup. So we have multiple cameras here to watch droplets drying, and we have a nanoliter dispenser with which we can apply droplets on different substrates. And we do this in this kind of small drying chamber where we can apply different convective conditions to the droplets, realized with this air supply. And basically what happens is as when you have a droplet on a surface, the escape probability of molecules during drying is higher at the edges. So if you would plot the evaporation flux, it's actually higher in the edges of the droplet than in the middle. So what happens is, if this is a colloidal droplet, if there are particles or solids inside, they form this coffee ring called structure, sort of a volcano or ring-like structure instead of this bulk. And we can analyze these structures with our white light interferometer after we dried the droplet, and there you can see a picture of this of such a scan where we obtain a height value for every pixel that we scanned, and therefore can calculate the structure's volume and later on the porosity and the internal structures and cavities.
Here we got another dryer, a microwave dryer in our faculty. We are investigating drying methods with assisted microwave drying. We got a drying chamber and we try to dry clay bricks that are shown here inside already. We got two magnetrons on each side with a power of 1000 watt. So we can indicize the amount of energy up to 2 kilowatts. And here we got an example, a probe of a clay brick. It's already dried, but by microwave drying. And we can measure the temperature inside with fiber optic sensors that we can put inside of the probe, so we can measure the temperature gradient from inside to outside. We got other temperature measurements through IR cameras that are pointed on the surface, and we can control the inlet air temperature, the outlet air volume flow through a van on the top of the apparatus. And I'm going to start it to show yeah, the different drying method, or the new drying method. Yeah, the turntable is turning during the entire experiment to obtain like an uniform energy input into the into the clay and into the brick. And yes, what else do we got? We got online measurement of the water content of the air through a dew point meter that we got on this side, and we got everything else connected to the apparatus. For example, we can measure the weight and therefore the weight loss that's obtained through the evaporation of the water. And as well, we can compare microwave drying with convective drying, because we can shut down the entire microwave to just do convective drying. And yes, it's to show the durability of microwave drying of clay. And yes, and if you want to have more information about our yeah, equipment and all that, yeah, just contact me. My name is Lucas Briest, and thank you for your attention.
Yeah, that's our micro-CT for measuring the morphology of single particles or also packed beds. Here we can see the source, the X-ray source. In the middle is the sample with the sample holder, and we have a movable carrier, so the sample will rotate in our case, not like in the hospital where the device is rotating over the around the sample. And at the end we have the detector who is detecting or collecting the source or the radiation. So then from these measurements here we will get this view here, and we will take normally around about 1,200 pictures of it, and from these pictures we create a 3D reconstruction of the original sample, which is here on the second screen visible for a packed bed, like here with these sample holder measured, and yeah, you can see directly in the sample.
So yeah, this is our scanning electron microscope, and we use it actually for analyzing surface of our particles and structures of our agglomerates, and yeah, we can use them for seeing a lot of details. So I just want to demonstrate how fine these structures can be. So, and we are also able to analyze with a special software the elements of these materials. So, and we can do it for several points of our sample. So this means that yeah, we are getting a good overview about our particles.